Okay, on problem number 16, it asks you to determine the number of different types of gametes that could be formed by individuals of the following genotypes. So we're trying to just determine how many different sperm or how many different eggs can be produced by each of these gametes. Now, if you remember, the equation for the different number of types of gametes is 2 to the n power, where n equals the number of heterozygous pairs. So in this case, count your heterozygous pairs. I see 1, 2, so my n equals 2, and I end up with 2 squared then, which is equal to 4. In part B, I only have one heterozygous pair, so my n equals 1, 2 to the first power equals 2. In C, I have 1, 2, 3 heterozygous pairs, so n equals 3. Again, my equation is 2 to the n power, so 2 cubed. So that's 2 times 2 times 2, which is 8. Part D, you take a look. Only one heterozygous pair, not heterozygous, not heterozygous. So n equals 1, and I get 2 to the 1 power equals 2. Part E, I have 1, 2 heterozygous pairs, n equals 2, so I get 2 squared, which is equal to 4. And part F, if you'll notice, F is going to be one, 2, 3, 4, 5, n equals 5, and you're left with 2 to the 5th power. Now, in each of these, it also asks you to come up with the gametes. So that asks you to think about all the possible combinations. So in part A, that could be a big A with a big B, or a big A with a little b, or a little a with a big B, or a little a with a little b. You can follow these patterns throughout these, where you would say, again, big A with big B. But notice, we don't need to write big A with big B twice, because we've already got that down once. And little a with little b. Again, showing 2 possible gametes and 4 possible gametes. You can continue this pattern on for the rest of the options.